Hi friends, welcome back to Edupedia World. Today we'll be discussing a new topic on sound and sound waves. This will be about characteristics of sound or characteristics of sound wave. We'll confine ourselves to the discussion of loudness and intensity in this particular class, and the rest of the characteristic we will discuss in the next class. So let's start with the characteristics of sounds. Two different sounds can be distinguished from one another by one of the following three characteristics. Those three characteristics are namely loudness of the sound, second, the pitch of the sound. Sometimes it is referred to as how shrill is the sound. How shrill is the sound. And finally, the quality of the sound. Quality of the sound. It's also referred to as the timbre of the sound. So these three characteristics help us distinguish between two different sounds we hear. We will take up each of them one by one and discuss them in details. So first, let's start with loudness. As the term suggests, loudness is a representation of how loud the sound is. So basically, if two sound has same pitch and same quality, then loudness is the characteristic which will distinguish those two sound. Okay, so we can say that loudness represents how loud a sound is. It helps distinguish a faint noise from a loud one. Now this seems very theoretical. How do we actually express loudness, or what is the property that makes a sound loud or faint? Let's see. If we characterize loudness is the effect of the amplitude of the sound. So to make it more understandable, say we have two different sound. This is displacement versus time graph. Let's say one follows something like this. So this axis is the displacement, let me represent by D, and this axis is time. So for this particular sound, this is my amplitude A1. Now say I have another sound which follows the path like this, as in it replicates the first sound in where it. So what we see is the wavelengths are the same, the frequency is the same. The only variation here is the amplitude. So here my amplitude turns out to be this much, A2. So let's say this as 2 and this is 1. So the amplitude of 1 is less than amplitude of 2, and this manifests itself as 2 being loud, 2 being more loud than 1. Okay, so given the pitch, which we'll see is a manifestation of the frequency, and quality, which we'll later see is a manifestation of the waveform, are same for the two waves, the difference in amplitude determines which one is a louder noise or louder sound. Okay, so this kind of gives you a qualitative idea of what loudness is. Now there is another term which is more objective. Loudness, as we can see, is kind of a subjective idea. You feel how loud the sound is, but it might be that for you one sound may be really loud, for someone else it might not be that loud. So it kind of is a gray area. So to undo this subjectivity, a concept known as the intensity is introduced. Intensity of sound. Now what is intensity? Intensity is defined as the amount of energy that is sound energy passing per second, normally through unit area at a given point. So intensity basically determines how much, given you are at some point A. Let's take an example to see. Suppose there is a source of sound here, source, and you are, let's say, standing here. Here you are as an observer. So the sound waves will travel in all directions, and some energy of sound which is traveling towards you, you will obtain it. So if we were to draw a unit area here, if we could draw a unit area here which is normal to the direction of, perpendicular to the direction of sound traveling, then how much energy is being observed by this unit area would define the intensity of the sound at that point, right? So more the amount of energy passing through a given area, obviously the intensity should be higher. Lesser the sound, intensity will be lower. Now there are, since this is a objective quantity, that is, you can measure how much energy is passing through the unit area, this is different from loudness. Now to give you some rough estimate about how much intensity corresponds to how much loudness of noise you hear, intensity of 10 to the power minus 6 watt per meter square. This is ordinary conversational sound range, ordinary sound, and 10 to the power minus 12 watt per meter square. This is the minimum intensity of sound that a human ear is capable of hearing. This is the limit of sound. limit of sound audible to ears, right? So any intensity less than 10 power minus 12 watt per square meter will not be audible to human ears. Now that we have a rough idea about the magnitude and how much loud the sound corresponds to what magnitude, let's see some of the properties on which the intensity and loudness of sound depend. Some of the factors on which the intensity of the sound will depend, and ultimately, since intensity will depend on them, the loudness of sound will also depend on them. So the factors on which intensity will be depending is: one, the square of the amplitude, square of amplitude of the sound wave. Second is it depends on the square of frequency, proportional to the square of frequency, and the density of the medium. Density of medium. We will see in details how these things affect. But before that, let us take a moment to discuss the subjective nature of loudness and the objective nature of intensity. As I gave you a brief glimpse that since intensity is a measurable quantity, that is, you calculate the exact amount of energy passing through a area normally per unit area, that means that intensity is a objective quantity, you measure it precisely. But loudness is kind of a subjective quantity because two persons might perceive the same noise being differently loud, right? It also depends on how sensitive your ears is to sound. Therefore, for subjective measurements, loudness is a pretty good measurement, but for objective scientific measurements, intensity is the one to go to, right? Now that we have seen the factors affecting intensity, let's note down the factors on which loudness of the sound depends, and it's kind of correlated with the intensity of the sound too. So factors affecting loudness. Let me use different color. One is it's proportional to the square of amplitude. So higher is the amplitude, more is the loudness. This is kind of the basic definition from where it comes. So there is no surprises here. Second, the loudness varies inversely to the distance from the source. So what does this mean? Is suppose you have a source of sound here. If you were at a distance say d and then someone else was at a distance 2d, then what would happen is the loudness heard by you or the first person is 4 times the loudness heard by the second person, because by the time the sound reaches here it has expanded in further surface area. Therefore you hear less loud sound or less intensity sound, this both being correlated, right? So you get the idea about inverse relation with the distance. Third, loudness depends on surface area of the vibrating body. Given everything is constant, if the surface area of the vibrating body is more, then more energy will be released out of it, right? More energy will be released out of it, and as a result the loudness will be more, also the intensity will be more. So fourth point on which loudness will depend and in effect intensity will also depend is the density of the medium, as we have mentioned here. Similarly here too, density of medium, and it is found that more dense medium equals more loudness. So if medium is more dense, then the sound heard would be louder. And finally, there is a factor of the presence of resonating objects. Presence of resonant bodies. Suppose there is a body which resonates with the sound form or the sound wave that is coming. As we have seen, that resonance kind of leads to increase in amplitude by a large amount, and that increased amplitude will ultimately result in increase in the loudness, right? So these are the factors on which the loudness and in turn the intensity will depend on. You cannot say these are independent. This both things are dependent. Okay, now let us formally introduce the relation between loudness and intensity. We will try to mathematically relate what is loudness in terms of what is intensity. The loudness L has been defined to be equal to K times log of intensity, where K is a proportionality constant. So this is a constant, and though loudness is a sensation rather than actual measurement, scientists have thought out this relation as the best representation of the relation between intensity and loudness. Let us see the units of loudness and what is known as sound level. So the units of loudness is known as a phone, and the unit of level of sound or sound level is represented by decibel. Also there is bell, which is basically 1/10 of decibel. Okay, so now what is the difference between phone and decibel? What happens is the two are related only at a particular frequency, that is 1 kilohertz. So for similar property, similar frequency sound, one phone is loudness of sound equal to the loudness of 1 decibel, both at 1 kilohertz, rather given both at 1 kilohertz. So one phone at 1 kilohertz, the loudness of it will be equal to 1 decibels loudness at 1 kilohertz. So this is the factor that kind of joins the two units together. Now let us see, we have seen that the loudness can be correlated with intensity using this equation. Let's say we have two scenarios. One is intensity I1, second is intensity I0, sound level loudness L1 and L0. So using these equations, what we can say for the first one, L1 is equal to K times log I1, and this is L0, sorry, this is L0. L0 is K log I0. Now using these two, if we try to find the difference between them, L is L1 minus L0, that turns out to be K times log, base is 10, I'm not writing it each time, log I1 minus log of I0, which implies L is K log base 10 I1 upon I0. Okay, and this I0 is taken by convention as the minimum intensity audible, that is 10 power minus 12 watt per meter square. So using this value for any given intensity I1, we can find the loudness of it, and that will give us the loudness in units depending on what the value of K is. So let's define K. If K is equal to 1, L turns out to be log 10 I1 upon I0, and this is the loudness in the scale bell, not decibel. Now if we replace the value, that 1 bell is 1 upon 10 decibel, rather it should be, this should be 1 bell is 10 decibel. Sorry about that. Kindly rectify this error. So if we replace that, L will turn out to be 10 times log base 10 I1 upon I0 bell, rather decibel. Okay, so this is decibel is the most commonly used unit for loudness, and the relation for it turns out to be 10 times log base 10 I upon I0, where I0 is 10 power minus 12 watt per meter square. Okay, now for comparison's sake, let us say we have intensity which is 100 times that of I0. If we replace that, let's say I1 is 100 times I0, then what we'll get is L is 10 times log base 10 100, and log 10 is 2, that is 20 decibel. So increase in 100-fold of intensity leads the loudness from 0 decibel to 100 decibel. Okay, a point of note is if we take I1 exactly equal to I0, then the loudness turns out to be 0 decibel. So the minimum sound level, that is 10 power minus 12 watt per meter square, corresponds to a loudness of 0 decibel. Fine. So these gives you an idea of the different units of loudness of sound. Just to give you a rough estimate about how loud is really loud in terms of decibel, a normal conversation is normally in the range of 50 decibel. A air jet taking off is in the range of 140 decibel. Anything above 110 10 decibel is going to be very uncomfortable for our ears. So this gives you a rough idea about how loud is loud, and noise pollution is normally considered to be caused by sound levels which are really harsh, above 120 decibel, and constant hearing to loud noises above 120 decibel may lead to permanent ear damage, and temporarily it can lead to headaches. So that is the source of noise pollution, the loudness of sound. Okay, so this whole lecture has been a lengthy one, and you came to know about loudness and intensity, the factors on which they depend, the units for both of them, and this was the first property by which you can vary, characteristic by which you can vary two different sounds. The rest two characteristic we will discuss in the next class. So till then, have a great day. Goodbye.